Okay. There are two things that I want to know about each of the shapes on this page. What are the two things I want to know about them?
The perimeter and area.
Perimeter and area. How do you find the perimeter of a shape? Add all the sides. So if I was going to describe the perimeter to somebody, like the perimeter of this room, what would the perimeter of this room be if I was going to walk it? Yes, all the way around the outside, nothing in the middle. I'm just going to walk around the edge. Do I have enough information to find the perimeter of this shape? Well, let's start walking around it. I need to know all of the sides, all of the edge pieces, and then we're going to add them all together, right? When I do this on my own, especially with an irregular shape like this, I'll draw around the edge to make sure that I get every piece and only the pieces that I need. So if I started walking around the edge, this side is how big? 7 feet. So I need 7 feet. And then I'm going to turn and come down this way. How big is that? 4 feet. Where would I need to walk next?
Oh, the little edge thing.
I need this little ledge. I don't have that little ledge, do I?
Nope.
Do I have any way of finding that little ledge?
Yes. Don't you do 4 minus 5 or something? No, wait. No, I know what I'm talking about. It's 7 minus 5.
7 minus 5. That would be if they lined up perfectly. I like what you're thinking.
No, 4 minus 3.
4 minus 3. Well, hold on. Let's think through this. Let's pretend for just a moment. Oop, let me draw that a little bit better. If these were lined up perfectly, 7 feet, this bit here is 4 feet, 3 feet. Could you tell me how big this side is?
Yes.
Yes. How big is that? How much? 2 feet, because we know down here is 5 feet.
Yeah.
So this would have to be 2 feet, right? They took it and they shifted it over, but we still know that this little bit and this little bit would have to add up to be how much?
7 feet. No, wait.
It has to add up to be 2 feet.
Has to add up to be 2 feet?
No, that's not right. It
Yeah.
has to add up to be.
We-
Okay, can you say it again?
Yep. We actually don't have enough, do we?
So you gotta be point something.
So I'm going to have to tell you how big that little ledge is.
Oh, yeah. You can do all that.
Well, you got to know what you're thinking through.
But did you know what I was talking about when I was saying subtraction?
Mhm.
I told y'all.
Yeah. And we are going to have to use some of that on here. This one right here, guys, is 0.5. And there's no way that you could know that except I told you that.
Okay. All right.
0.5 feet here.
So it's not gonna be on the test.
I'm not going to make you guess how big something is. I have to give you enough information to figure it out. All right? Am I all the way around this shape yet?
No.
Okay. Where else do I go?
To 3.
I go down here, which is 3 feet.
To the left.
And then I'm going to turn to the left and walk how far?
5.
5 feet.
Then you'll go up 3 feet.
Go up 3 feet.
Then to the left 2 feet. No, that's 2. But she just said it.
Well, let's look.
Boy, we just said it.
Hold on. There we go. We know this has to be 3 feet. We said this little ledge here was how much?
0.5.
0.5. This whole side, including that little ledge, would be how much?
4.5.
Yeah. This whole thing right here would have to be 5, which means this much right here, ooh, let me change colors, is 4.5, 2.5. So we're going to turn and walk 2.5 feet here.
I mean, I was close.
You were very close. I'm really, really proud of you on that. Am I all the way around this shape yet?
No, you got one more side.
One more side. How big is that one more side?
4 feet.
4 feet. So we're going to turn and walk. Now I've gotten back to where I started. So now I know all the things that I need to add up. That is an awful lot of numbers, isn't it? Do you know what happens to me when I put that many numbers in my calculator?
Confused.
Error.
I always type one wrong. I always end up with the wrong number. So as much as we can do in our heads to give it fewer numbers to put into the calculator, and it doesn't really matter how you group them, but I'm going to do it just like straight across here. So 7 and 4 makes what if I put those together? 11. If I look at these three right here,
3.0, 8.5.
8.5. What about these two together?
5.5.
5.5. And then I've got this 4 on the end. Now I only have 4 things to put in my calculator. Much less chance I'm going to make a mistake now.
Couldn't you just do all
5 plus 9.5 is?
You don't have to group them this way. This is just the way I chose to look at them and group them. Some people look at them and like to make groups of 10s.
I was gonna say you could do the decimals last. So you
Mm-hmm. Yeah, you could absolutely do the decimals last. I'm just saying I would never take a string of like 8 numbers like this and type it into my calculator because it's not going to all fit on my screen. And whether I'm using my cell phone calculator or a regular calculator, like buttons stick, my fingers miss, and then I end up with the wrong answer, even though it's just simple addition. What'd you guys get when you added those all up? 29. 29 what?
I got 30.
Feet.
Wait, I'm confused.
Try it one more time. Should be 19.5 plus 9.5. What else do they want me to find here? Area. How do you find the area?
1/2 base times height.
That's for a triangle. No, I like that. We're going to use that later.
Oh wait, it's 1/2 base times length times height.
Take out the 1/2
Or
and then
width,
yes.
Or the width.
Area for a rectangle is equal to length times width. Are we working with just a rectangle? This whole shape could be described as just a rectangle.
Okay, now I got 30 words.
No. So how am I going to find the area of the whole thing?
Okay, so you split it in half and you find the triangle first and then the other one first.
Yes, so we are going to split this irregular shape into normal shapes. And then what will I do with the area of the normal shapes? Add them together. So what normal shapes do you recommend? 2 rectangles. I like it. So let's look at the top rectangle first. Tell me about the length and the width of the top rectangle. 7 feet by what?
4.
By 4 feet. So what's the area in here? 28. 28 what? Feet squared. 7 feet times 4 feet. 28 feet squared. And then I need to add that to the area of the other rectangle. So tell me about the length and the width of the other rectangle.
15. Oh.
Yep.
Yeah.
15. 5 feet by 3 feet.
And you add them, right?
Yep. So I get 15 feet
43.
squared. So now we add those. You said 43. Is that going to be 43 feet, 43 feet squared, 43 feet to the 4th? What happens to my feet?
It's feet squared.
Feet squared. Why is it feet squared?
Because you're only adding them, not multiplying.
Yes, the only time exponents are going to change is if we're multiplying things, just like with my x's. X times x gives me x squared. X plus x is 2x. Same thing happens with feet and inches and centimeters and meters. So we have 43 feet squared. Look down at number 2. This one has some weird little marks. What do those weird little marks mean? Yes, means congruent or that they are the same size. So same number of marks equals same size. So how many sides overall do we have that are 6 millimeters? How many sides total? 6. These 3 on the top part, and then down on the bottom, we have one right here, one right here, and one right here. How many sides do we have that are 12 millimeters? 2. We've got this guy, same number of marks, so same size. I want you guys to find the perimeter. Find the perimeter. Did you get a number bigger than 10?
Yes.
Bigger than 20?
Yes.
Bigger than 40?
Yes.
What'd you get? 60. 60 millimeters. We add 6 by itself 3 times. Oop. And then we add 12. And then we add 6 3 more times. And then we add 12. Or you could add 18 and 12 and 18 and 12, or 36 and 24. Remember, the fewer numbers you put into the calculator, the better. You want to make sure that you're doing it correctly. But the fewer numbers you put into the calculator, the less chance of making a calculator mistake. How are we going to find the area now? Is this a regular shape?
No.
So what should we do? Cut it into 2 rectangles. Where should we make that cut?
Right down the middle where they don't match up.
I like that answer. Is that the only way to do it?
No.
No. There's other ways you could cut this up. As long as you cut it up into regular shapes and find the area of those regular shapes, add them all together. I think this is probably the easiest place to make a cut. What would the area of the left-hand rectangle be? 72. 6 times 12. We'd get 72 what? Millimeters squared. What do you notice about the other rectangle? It's exactly the same. It's a 6 by 12. So we'd have 72 millimeters squared, which means what about our area then? It's how much? 144 millimeters squared. You guys are doing great. Let's look at the next one.
The area is always going to be squared.
Yes, area is always going to be squared because we're always going to be multiplying 2 dimensions together. Whether it's a rectangle with length and width, or a triangle where it's base and height cut in half, we're always going to be multiplying to get that area. With the perimeter, it's just adding all the way around, and that's why it stays just our regular units. Yep. I want you guys to do number 3. I'm going to give you guys about 4 minutes on this one before we start talking through it. Do you have enough information with just what's printed on the picture to determine the perimeter? Just what's printed on the picture. How big is the side across the bottom?
11.
11. Tell me how you got it.
6 plus 5.
6 plus 5. We bring this down here. I know that this side would have to be 5 meters. This right here would have to be 6 meters. So all together would be 11 meters.
So it wouldn't make sense if I cut it like this instead of.
You could have cut it that way.
But it wouldn't make sense because the 4 on the other side would be 4, but then on the 10 side, you could split it in half, or it could be 5, but it's 4. Do you understand what I'm saying?
I do understand what you're saying. Here's what we're going to have to look at for that.
Okay.
So as I'm walking around finding the perimeter of this thing, I know I've got this 5 meters here, right? And then I turn and go up, I've got 4 meters. 5 meters plus 4 meters. Then I go across the top, and that's how big? 6 meters. Then we come down the right-hand side. That is how big? 10 meters. We go across the bottom. And you guys told me the bottom was how big? 11 meters. Am I all the way around this shape? No. I still need one more piece of information, don't I? How big is that side over there that I'm missing? Ooh, I'm getting 2 different numbers.
Wait, what happened? What were we asking for?
How big is this side right here?
No, this sheet right is 6 meters.
Oh, it's 6.
Ooh, I got 3 different numbers. 4,
No,
5,
no.
and 6.
No, it's 6.
Why is it 6?
No, it can't be 6. Because that side doesn't match the top 6 side.
This side over here would be how big?
Why would it
4.
be 6? It's 6. You only got one.
Okay.
person
This would be 6 meters, which means this, right, or sorry, would it be 4 meters? Why did I write 6? Because it makes a rectangle,
now.
right?
Oh, that makes sense.
So this would be 6, because it has to all add up to how much? Has to add up to 10. So this has to be 6 meters, which means over here has to be 6 meters. So we need to include that as we're walking around. So when I add all those up, what do I get? 42 meters. Area. We can cut it into these 3 rectangles here. You can cut it into 2 rectangles. Could we just leave it as 1 rectangle? No. I have to cut it into at least 2 rectangles. What do you guys want to look at? All 3 pieces, or do you want to look at just 2? Just 2? Okay, so tell me what the 2 are that you want to look at. Top one and the bottom one. So tell me about the dimensions of the top one. 6 and then 4. So what's the area on the inside? 24 meters squared. And then we've got the bottom one, which is much longer. Tell me about the dimensions for the bottom one. 11 by 6. Language. So what's the area for that? 66 meters squared. So the whole thing is how much? 90 meters squared. Come on, ladies. I want to do one more problem with you guys. If you turn the page, I want to look at number 5 together. I want to look at number 5. This one is disgusting looking. The others have all been different rectangles. What makes this one so much grosser?
Because it has too many curves and the edges and bumps.
Lots of edges and bumps, right? So talk to me about the only piece of information we're missing.
You're missing the hypotenuse of the
Yes. Is it a right triangle?
Yes.
Yes, it is. We're missing the hypotenuse, so we don't know how big C is here. How can I find that?
Pythagorean Theorem.
Pythagorean Theorem. A squared plus B squared equals C squared. So what pieces of information do I need? I need A and B. Where are those on my triangle? Yeah. I need this. And I need this. Do I know either one of those?
No.
Can I find them?
Yes.
How can I figure out the one that I did in like this blue color?
Subtract.
Subtract what?
20 minus 15.
20 minus 11. Why 20 minus 11?
Because you have to have the 5 and the 6.
There we go. If I bring this over here,
Finish?
I know that this is 5 meters. This one right here would be 6 meters. The whole thing adds up to 20. So 20 minus 6, I get 14 minus 5 is what? 9. So this bit right here is 9 meters. So that's how big this side is. So now I know A. 9 squared plus, how do I figure out the purple one?
16 minus 6? Or, no, wait, is it 8? 6? It's going to be 6. Because it matches the top.
Does it match?
No, because it doesn't have a... Oh, wait, maybe it's...
It doesn't have a little mark on it, so I don't know for sure. What could I use? Can we use 8? Well, where are we getting 8 from? I like your ideas. Talk to me about where we're getting these things from.
I think this is like a half of 16.
Half of 16. I don't know for certain that it's half.
It is not because it's a right triangle symbol, isn't it?
It's a right triangle, but I don't know that it's isosceles.
No, I'm talking about like on the other side. Like,
This guy right here?
yeah, wouldn't that indicate that it's half or no?
Not necessarily. It's perpendicular, but we don't know that it's a bisector. But it is perpendicular. So follow this side up. If I completed this right here, how big would this be? 6. Can I use that information now to figure out how big this would have to be? How big is the top? 15. And I know that that little bit over there is 6, right?
Yes.
Okay. 15 minus 6 is how much? 9. So this is 9 meters. How can that help me?
Wouldn't, so if the bottom is 1 more, wouldn't you just add 1 to it? So then that this is 10? No. I mean 7.
7. Why 7?
Because you have 6 on the other side where the orange is, and then if the other half is going to be the same on the bottom too, because you split it in half. And then, I don't know how to put it into words, but yeah.
Opposite sides on a rectangle are going to be the same size. So if I know up there where it matches this bit right here, if that's 9 meters, then this bit would have to be 9 meters also, right?
Yeah.
But this adds across to how much? Yep, adds up to 16. So 16 meters minus 9 meters, 7 meters.
16 minus 9. Oh my God. I swear I was about to say that. What?
All of that work because we're trying to figure out what?
A side.
A side. Which side?
A Pythagorean Theorem side.
Pythagorean Theorem side. We've got this hypotenuse over here, and we need that so that we can find the perimeter of this whole thing. What is 9 squared? 81 plus 49 equals C squared. 81 plus 49 is 130. Is that going to come out to be a nice, pretty whole number?
No.
Round it to 1 decimal place for me.
Wait, we have to square it.
Yes. You get how much? 11.4. That was a lot of work for 11.4 meters. Do I have enough now, though, to find the perimeter?
Yeah.
Yes.
Find the perimeter for me. is correct. 79.4 what?
Meters.
Meters. Now that we've done all this work, the area should be a whole lot easier, right?
We have 3 areas. We're gonna have 3 areas.
3 areas. What are the 3 shapes we're going to be looking at?
2 rectangles.
2 rectangles. Tell me about one of the rectangles.
One of them on the side will be 16 times. Well, no, it'll be 6 times 6. I mean,
6
6
ti-
times 15. Sorry.
6 times 15. We can do that one. Yep.
Okay, and then the other one will be 20 times 9, right?
Is it going to be 20?
Oh, wait, 14 times 9.
14 times 9. This isn't the only way to split it up. And then we still need what shape?
The triangle.
The triangle. How do we find the area of a triangle?
1/2 base times height.
1/2 base times height. What is the base? 7. And the height? 9. So now I need my handy dandy calculator. 6 times 15?
6 times 15 is 90.
90. So 90 meters squared. 9 times 14?
126.
126 meters squared. And then we got to do that triangle. 1/2 base times height.
Right?
31.5.
I just divided by 2.
Yep. That's the same thing as multiplying by 1/2. So now we need to add all of those up. And what do we get?
247.5 meters squared.
You said 247?
Yes.
0.5 meters squared. Nice work. There is one more thing I want you guys to do for me. You have the rest of the class period to do it. I'm grading it only based on completion. I want to see what you know, what you think, what you can do. There are 2 questions on the front and 4 questions on the back. All right. You guys need to turn this into the cardboard box before you leave the room. Like I said, I'm only grading it on completion, but you do need to get through as much of it as you can. If you answer thoughtfully, but you can't get all the way through it, that's okay. I'm looking for depth of answer and thoroughness.